Alrighty, last part of this section, we're going to be talking about the domain. So using correct notation, find the domain of each function. So we've got one function here. The only 5 points we're given are -3, 0, -1, 4, 0, 2, 2, 2, and 4, -1. So for the domain, we're going to label that with the lowercase d. Our domain for this one, we only have these 5 points, and for all we know, those are the only 5 points in this function. So we're just going to write those down. We have -3, -1, 0, 2, and 4. That's it. We technically don't know that there's anything in between those points at all. The next one's going to get a little more tricky. So the next one, the domain for this function, this is the volume of a sphere. So we have v equals 4/3 pi r to the third. The only variable, the input variable we're going to be using there is r. So when we're doing this notation, we're going to start off by identifying the letter r. Oops, sorry. We're identifying what the input variable is, and that in this case is r. The next part of this, we're going to tell you what types of numbers you're allowed to plug in to this function. Now that seems kind of weird. Like thinking about volumes, we can plug in 6. We have a radius of 6. We could plug in 1,000,000. It'd be a really large sphere. You could also plug in like 0.1, which would be very small, depending on the unit, I suppose. So we're going to say r is, and then we're going to use this. This is called the element symbol. So now let me shift over here. So the way we read this is r, and then we're going to say is an element of, that's what that little E looking thing. It's kind of like a C, but E, and yeah. This next symbol we're going to use, hopefully is familiar to you. That's the real number symbol. Some of you will draw it like that. I typically draw an R and then write a line or kind of a slash through it. Some people do something like this. I don't really care what you do. This is the way I'm going to do it, just so that it's got kind of a double bar. But that's the real numbers, the real number symbol. So this is saying my R values are all, or it can be any real number. But is there anything that it can't be? So it's any real number, but can I plug in like -2 feet? Can I have a radius of -2 feet? That doesn't make sense. So what we're going to do is we're going to draw this division bar here, not division bar, but like the bar to divide this part in half. And sometimes you'll hear this read as such that. And the rest of this is going to be kind of a clarifying. It's like, okay, this is true as long as this other part is also true. So we can use any real number that we want as long as r, our radius, now thinking about radius, it's a measurement, it's a measurement of distance to be specific, it has to be greater than 0. You can't have a radius of 0 on a sphere because then you don't have a sphere, you just have nothing. You also can't have a negative radius. So r is an element of reals, or the reals. That means I can use any real value that I want for the radius as long as it's such that r is greater than 0. Let's try a couple more of these. Next up, h of x equals the square root of 4 minus 3x. So we're going to say, our domain, D. The variable we're using is x, and we're also going to be using the real number. So x is an element of the real. So that means we can use any real number that we want, but can we just leave it like that? Is it okay to plug in any real number? Well, taking a look at what we have here, let me switch my window a little bit. We have a square root of 4 minus 3x. Underneath that square root, we know we need to have a non-negative answer, or non-negative value, because otherwise we'll get imaginary numbers. So that means our 4 minus 3x has to be greater than or equal to 0. So we got to figure out what values of x make that true. So let's solve this. Let's do subtract 4 from both sides. I'm just going to run this horizontally. So we have -3x is greater than or equal to -4. Now we want to just get x all by itself, so let's divide both sides by -3. Now on the left side, we're just left with x. On the right side, -4 divided by -3. Fractions are our friends. We're going to leave it as 4/3. But you notice that I also skipped that inequality symbol. Remember, anytime you're working with an inequality, so something that involves a less than or greater than, or less than or equal to or greater than or equal to, if you multiply or divide both sides by a negative number, you got to flip the inequality. So it started off as a greater than or equal to. Now it's going to flip to a less than or equal to. Every x value that we plug in has to be less than or equal to 4/3. So we're going to say x is an element of reals as long as our x's are less than or equal to 4/3. So 4 over 3, it's 1.333 repeated. Let me give you an example of why this must be true. If you were to plug in 2, so if you were to do the square root of 4 minus 3 times 2, you end up with square root of 4 minus 6, which would give you the square root of negative 2. And that's going to give us a non-real value. Any x value larger than 4/3 will give you a non-real output. So we got to be careful with that. Letter D. F of x equals 5x squared plus 2x minus 1. This first part, you're probably going to get pretty familiar with it. We're going to say x is an element of the reals. That means we can plug in the real values into this and it'll work. Now we have to ask ourselves, are there any real values that don't work? So I always start off by going like, okay, can I plug in positive numbers? Can I plug in positive 75.3? Sure, it's going to be a big number, that's fine. Can I plug in negative numbers? Can I plug in negative 12.98? Yeah, that'll work. I can square negative 12.98, and I can multiply it by 2, and I can do all that good stuff. Can I plug in 0? Sure, 5 times 0 squared plus 2 times 0 minus 1, no problem. So are there any values that we can't use? Nah, we're good. We're going to actually just close this off. There's no other exceptions. So we're going to say x is an element to the reals, call it good. So that means we can use any real number. There's no restrictions. We don't have to say, well, x has to be greater than 0. No, we're done. We can use positive numbers, negative numbers, decimals, weird fractions, whatever. They all work. Letter E, 3x over x plus 5. So this first part, again, get familiar with it. We're going to say x is an element of the reals. We can use any real numbers except, wait, are there any exceptions? Let's take a look at this. What do we know about fractions? We can't divide by 0. So, can't divide by 0. So that means x plus 5 has to be greater than 0. Got to be greater than 0. Let me rephrase that. I'm actually going to backtrack, and I don't feel like starting this video over. X plus 5 doesn't have to be greater than 0. You can end up with a negative denominator. We just can't have it equal to 0. So, in order to solve for that, we're going to subtract 5 from both sides, and we end up with x not equal to negative 5. So this one, let me shift that over a little bit. This one doesn't have an inequality. It has, well, I guess it does. It doesn't have the inequalities that we're more familiar with, the less than, the greater than. It has the inequality of not equal, literally unequal. So we're going to say x is not equal to negative 5. It can be any other x value. It can be negative 4. It can be negative 6. It can be negative 5.1. It just can't be exactly negative 5. That's kind of goofy. One more. So we have g of x equals square root of x plus 6 over 6 plus x. So this one's got a bit of complication to it. So we're going to start off the same way. X is an element of the reals. But now we have two things we need to worry about here. We need to worry about the numerator and denominator. So going with this numerator, we know x plus 6 has to be greater than or equal to 0 because we can't take the square root of a negative number. Our denominator here, we're going to say 6 plus x can't be equal to 0. It can be negative, it can be positive. We're just going to say not equal to 0. Now let's solve both of these. I'm going to do the top one first. We're going to subtract 6 from both sides. And we end up with x has to be greater than or equal to negative 6. For the second one, we're going to subtract 6 from both sides. And we're going to get x is not equal to negative 6. So the top part says it has to be greater than or equal to the bottom, or negative 6, but the bottom says it can't be equal to negative 6. So we're going to kind of merge those two together. So the first, again, the top part has to be greater than or equal to negative 6. The bottom part says we can't have it equal to negative 6. So we're just going to compromise, and we're just going to say, okay, well then, x has to be greater than negative 6. Can't be less than, because the numerator a lot says we can't have the negative, can't have it less than negative 6, because that would make the numerator a square root of a negative. And it can't be equal to negative 6, because the denominator would be then 0, or be equal to 0. So therefore, it has to be exclusively greater than negative 6.